Hello and welcome to this video on blood typing. Blood typing for most people is the ABO system. Those who know a little more may think of the rhesus typing. Those are just some of the considerations that define what your blood type is. For most reasons, the basic ABO blood type is enough, and more so for those that also use rhesus blood types. That gives you the positive and negative versions of A, B, O, and AB. Each of these labels is going to tell you two things about your red blood cells, which are properly called erythrocytes. Each of your red blood cells has an antigen on its surface. These are small saccharides or sugars that are specific to the A, B, O, or AB blood type. That is, either the A, the B, or the O has its own antigen. The caveat to this is that the AB blood type carries both A and B antigens at the same time. You'll find that different ethnic or national groups carry different distributions of these. You find that for the most part, O makes up about 44% of the Caucasian population, 49% of the black population, and 43% of the Asian population. B makes up 9% of Caucasians, 20% of black people, and about 25% of Asian people. A blood type makes up about 43% Caucasians, about 28% of black people, and about 27% of Asian people. AB makes up about 4% of Caucasians, 4% of black people, and about 5% of Asians. The rhesus blood type is another antigen, much like those found for AB and O. This antigen is a historical artifact, or at least the naming is. When rhesus macaques were used, blood would either respond to this by clotting or not. If your blood responded, you were rhesus positive. If you did not, you were rhesus negative. Hence the naming scheme. There are more, let's say, current methods which simply label as D positive or D negative. The response is all down to antibodies, and these antibodies bind with antigens. This creates a collection of multiple blood cells that come together. These form aggregates that are obvious clots or dark dots of material, separate from the plasma. This is true of blood type tests, but it's not what happens in your body. In your body, these antibodies cause haemolysis, or destruction of red blood cells. But the key here is your body will not make antibodies to your own blood type. So if you are an A blood type, you will not make A antibodies, but you will make them against B cells and O cells. Further to the basic ABO system and rhesus type, you have a range of subtypes of each of these. These are the result of your genetics, and the subtype will play a big role in the issue of autoimmunity. If you get blood that is a variant of the ABO or AB type, your immune system can react to it. That is, your immune system can recognize if blood you get is the wrong phenotype. Small changes between the different variants of the ABO types can be recognizable by the immune system. Since your immune system does not make antibodies against your own red blood cells, you would normally be fine, but the small difference in phenotype can be enough if you repeatedly get transfusions. This is because the repeated exposure to those ever so fractionally different variations on the ABO blood type is enough for the body to figure out that it's not your own cell. But again, you need repeated and regular exposure to these. It is a practical application of the expression of throw enough shit against the wall and eventually something will stick. This can happen when, say, you have leukemia that prevents your body from making red blood cells. The only way you compensate for this is to receive transfusions. Other conditions that can create similar requirements include sickle cell anemia, hemophilia, and more. This is one reason why you need to be very careful when it comes to transfusions for those who are going to get them on a regular basis, and why simply having the ABO system and the rhesus typing is not enough. Another example, and is perhaps one of the more common and important exceptions, is if a mother and a developing fetus have different blood types, but especially if they have different rhesus blood types. The most common example is going to be rhesus blood typing, where you have an AB, O or AB mother who is rhesus negative, but a fetus that is AB, O or AB positive. That positive rhesus type is enough for the immune system to recognize it as being foreign. And the problem with this is very simple. When you have this situation, you can cause the mother's immune system to attack the fetus, and it's called hemolytic disease of the newborn. Treatment for this generally involves some sort of immunosuppressant or way to block the antibodies for the rhesus blood type. As mentioned, for most people, simply knowing that if you are A, B, O or AB blood, and if you're rhesus positive or negative, is more than enough, as you rarely would have to worry about anything more unless you get blood transfusions on a regular basis. You're more than capable of giving blood donations and to receive blood transfusions safely with that knowledge. And it's really only if you need just one transfusion or want to donate. The information on variants of each blood type is used to increase the safety of blood transfusions for those who receive them on a regular basis. And this is where things get more complicated. The reality is things get more complicated as you either increase the frequency, increase comorbidities, or have other complications that require transfusions on a regular basis. Even small differences will be picked up by the immune system over time, and the more opportunities you provide for that to occur, the more likely it becomes. As you increase the number of transfusions, you risk haemolysis. This is otherwise simply called erythrocyte destruction. That's because your immune system will recognize them and start attacking the transfused blood red cells, but then it will also start to attack your own red blood cells. That means it loses its ability to differentiate between what is someone else's blood and what is your own blood. Normally, your own body and immune system will not recognize red blood cells as dangerous or foreign. This means you do not have antibodies against red blood cells that are your own kind. That is something your own body makes, and so you'll never make something against your own blood type. Doing that keeps blood circulating and functioning. Because your body does make antibodies to other blood types, if you get those, for example, if you're O positive blood and you get given A or B blood, or even AB blood, your body will try and destroy that because your body recognizes it from the antibodies that are circulating that it is foreign. On the other side of the coin, if you are, say, O positive, you won't have any recognition for any kind of O positive blood that you were given initially. And this is the problem, especially if you can get either the wrong blood type transfused, or even if it's the right blood type under the ABO and rhesus system, you might get a reaction, as there are a number of other antigens. And we'll go through a few of these, although not all of them, as generally speaking there's a very long list, and that incredibly long list is, to be quite blunt, capable of creating a lot of issues if you want to go through all of them. And for the most part, for a video like this, it's not necessary. When we look at the ABO system to start with, it is located on the 19th chromosome. It contains 3 exons. Those are 3 regions that translate into protein. The major protein of importance here is the fucosyl-transferase. This is what makes the H antigen. The H antigen is your antigen that identifies the blood group that you belong to. There's a particular group called the Bombay phenotype, which is a perfect example of this situation. Their body makes both anti-A and anti-B antibodies. This is fine under normal circumstances. It would mean that they're an O blood type. The problem is that they can't receive any blood except for those from another Bombay phenotype individual. And that's because the antibodies in their body would react to any blood except from someone in the same situation as them. And it means they always need a donation from a close relative. The reason why they need a donation from a close relative is that even if they're an A or a B blood type, they're not actually able to make the necessary antigens on the surface of their red blood cells. And this is why they have so much trouble with transfusions. The H antigen sites are what is particularly important for red blood cells, as they're largely responsible for a lot of what the body uses to figure out whether or not something is a blood cell. and overall, they're pretty much there to be able to tell you the blood type, and they're what you're using when you talk about the ABO system. Other than this, there are more than 44 possible antigens that are important. For this video, as said, we'll not be going over every antigen, but some of the more important or interesting examples. First, we have the Lutheran antigen site. This is part of the immunoglobulin superfamily. Fundamentally, it's an antigen saying, I'm one of your red blood cells, I'm not doing any harm, leave me alone, so the immune system won't attack it. Next we have the Lewis antigen, and this is a carbohydrate. This again is fundamentally saying, I am one of your cells, leave me alone, don't attack me because I'm doing my job. This is also part of what identifies the AB phenotype in particular. Then you have something like the Duffy protein. The Duffy protein is really interesting, not because it necessarily relates to your blood typing exactly, but rather what it allows you to do if you have this. The Duffy antigen prevents malaria from being able to enter the red blood cell, and this provides a lot of protection against malaria itself. Pretty much malaria has to have this as an entryway. The Dombrock variant is yet another, and this is a glycoproteins. Glycoproteins are proteins that are combined with sugars, and this again helps to identify that it's one of your cells. Then we have the aquaporin, which is one of the Colton variations, and this allows for the ability to move things in and out of the red blood cell. Without this, you don't get movement of, say, glucose into the red blood cell, which does still need to have food provided for in the form of glucose, which can be converted into ATP, even if the red blood cell itself doesn't have any other. Next is the Landsteiner-Wiener protein, which is another immunoglobulin superfamily member. These are again more indicators telling your immune system to leave it alone, and telling your immune system exactly what variant it is, so that, for example, if you receive a blood transfusion from somebody who doesn't have a matching version of it in their genome, your body may not recognize that the cell is something that you should be having, largely because you would have a blood transfusion due to massive blood loss. The NOPS variant is another glycoprotein, and it helps with the immune complex receptor. This is either CR1 or CD35, which means that immune cells, largely T cells, can come along, bind to it, and check that it is a properly acting cell. You then have the PRNP variant. This last one is more specifically a gene expressed for the blood cells to know what's going on. Although this does seem like something of a random list of possible names and functions, it's important to know that these are just a few of the many different variants and things that need to be looked at to figure out whether or not the blood that someone's going to get is going to be safe for them. For example, if they have cancer, particularly leukemias, where they're unable to produce their own red blood cells, you need to be able to figure out the right kind of blood to give someone, and that's one of the big things in transfusion medicine. Getting it as right as possible minimizes the possibilities of complications due to blood transfusions. Getting it wrong can create a world of hurt for whoever receives it. Having the ability to be able to check blood from a bank and basically request it specifically to suit a individual who needs certain things or needs to ensure they don't get certain blood means that you can minimize the amount of possible harm that, although doing good in terms of providing them with red blood cells, a transfusion might cause by leading to long-term haemolysis. Thank you for watching this video. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.